Hey there! In this video, I'll share with you an effective method for comparing the physical properties of ionic solids with simple covalent molecular solids. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. I love using a table when responding to questions of comparison. So let's use this table to set out the solution to our question for today. We'll start by comparing the melting point of ionic solids such as sodium chloride with simple molecular solids such as carbon dioxide. And yes, carbon dioxide can exist in the solid state. Melting point is the temperature at which a solid turns into a liquid, and for that to happen, we need to supply heat energy. That has to do with the amount of forces that are holding the particles together. In ionic solids, we have strong forces of attraction holding the ions together, and these forces are ionic bonds. In simple molecular solids, we have two forces at play. The forces holding the atoms in the molecule together, those are the intramolecular forces of attraction, which are the covalent bonds. Now, we are not concerned with those bonds for melting point. However, we are concerned with the forces of attraction between the molecules of carbon dioxide, and those can be referred to as the intermolecular forces of attraction, which are very weak. So we have weak intermolecular forces of attraction. Therefore, we need to supply a large amount of energy in order to weaken the strong ionic bonds in ionic solids. So, large amounts of energy required to break strong bonds. For simple molecular solids, however, not much energy required to weaken weak bonds. It therefore means that the melting point of ionic solids is high in comparison to the melting point of simple molecular solids, which is low. Let's now discuss the solubility of ionic solids in comparison to the solubility of simple molecular solids. So let's discuss water as a solvent. Water is made up of oxygen and 2 hydrogen atoms. H2O is the formula for a molecule of water. Now, the oxygen is bonded to the hydrogen, and that will be represented by these two lines. Oxygen is a highly electronegative element, meaning in bonding, it tends to draw the shared pairs of electrons towards itself. So the electron pair shared between a hydrogen and an oxygen atom, they are not exactly in the middle between the atoms, but they are closer to the oxygen than they are to the hydrogen. Therefore, the oxygen atom develops a slightly negative charge, represented by our delta with a negative sign here, and the hydrogen atoms develop a slightly positive charge. Therefore, water is a polar substance. It has two poles, a positive side and a negative side. When ionic solids dissolve in polar solvents like water, the ions separate. So the positively charged ion, the cation, sodium, will be surrounded by water molecules in such a way that the oxygen, which is slightly negatively charged, will be facing or closely associated by weak bonds to the positively charged cation. And the opposite is true for the negatively charged anion, in this case the chloride ions. Those ions will be surrounded by water in such a way that the hydrogen atoms in the water molecule, which are slightly positively charged, will be attracted by weak forces to those negatively charged anions. So when ionic solids such as sodium chloride dissolve in polar solvents such as water, the ions separate and become surrounded by the water molecules. In simple molecular solids, this is not so because there are no ions present. In fact, simple molecular solids are only soluble in non-polar solvents. One such example is tetrachloromethane. Another example is gasoline. Ionic solids, however, are soluble only in polar solvents. So to recap, the melting point of ionic solids is high, whereas the melting point of simple molecular solids is low. Also, ionic solids are soluble in polar solvents such as water, whereas simple molecular solids are insoluble in polar solvents such as water. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to use bonding structure to explain differences in melting point and the nature of water itself to explain differences in solubility between ionic solids and simple covalent molecular solids. Good luck on your exams, and I'll see you next time.